Hello, my friends, and welcome to another edition of What's New in Quix Streams. For those of you who don't know me, my name's Tim, and I'm a maintainer and contributor of Quix Streams. And today, we're going to be covering Quix Streams version 3.0. That's right, it's a major version bump, and it's a big one. We basically added StreamingDataFrame Branching and the ability for applications to read from multiple topics. And so when you combine the two, it dramatically expands the potential of the Quix Streams library. But before we get started, be sure to like and subscribe so that way you can stay up to date with all the latest features of Quix Streams. And you definitely want to do that because we have some other major features on the horizon. But with that, let's go ahead and dive right into 3.0. So the first thing that probably goes through your mind with a major version bump is, why the major bump? Well, for 99% of cases, upgrading should be absolutely seamless. All the functionality should remain the same, but there are some things that I do want you guys to be aware of. So the first thing is we are dropping support for Python 3.8. It's reached its end of life as of the recording of this video, so we're going to go ahead and rip that band-aid off now and drop support for it. So just go ahead and bump up to Python 3.9 or later. We support 3.9 through 3.12, and I generally do recommend use the latest version of Python that you can because there are some performance gains from using newer versions. So just a pro tip there. But some other changes that we have with application, we are now enforcing keyword arguments. And most of you guys are doing this anyway, which again, this is why for most of you upgrading is not going to be a big deal. But as an example here, you're not going to be able to just pass localhost here as an example. You do need to pass the keyword broker address. So just another thing to be aware of. Now, one of the things that is potentially breaking in the sense that it could be data altering is if you happened to use a named window. That is, if you did, like for example here, sdf.tumbling window, and you physically handed a name to it. We are changing some stuff under the hood for the sake of branching to where now that actually will cause a new topic to be created in this new version in order to support branching and using the same window in various branches. So just keep that in mind. It will mean that you will have some temporary inaccuracies until the window is fully populated again off of the new topic. So we're not backfilling it. Just be aware we're starting it from scratch. But as I mentioned previously, everything else should just be fully backwards compatible. We just want people to have hyper awareness as they upgrade because there were a lot of changes that happened under the hood. So just be vigilant and make sure you take a look and make sure that things are all functioning as you expect. And if you need any more details about what some of those changes under the hood were and how that affects StreamingDataFrame assignments, go ahead and check out our new docs section that outlines all those, along with pointing out some differences between 2.0 and 3.0. But beyond that, let's go ahead and jump into all the new features that we've added in 3.0. So starting off with our first major feature that we've added, and that is multiple topic consumption. So multiple topic consumption is exactly what it sounds like. It used to be that with an application, you could only use one streaming data frame, which meant you could only pass it one topic. Well, now multiple streaming data frames are possible. And so that means an application can now consume from multiple topics. And here's a very small example of how that would work, right? So we have here our application, and now here I'm defined two input topics, input topic A and B, and then a single output topic, but you could use more than one if you really wanted to. And so here, this is the key point. So we've defined app.dataframe here, and we've specified the topic that goes with it. And here we've defined a second app.dataframe with the other topic B here. And so between topic A and topic B, these will then be consumed simultaneously. And it's important to distinguish that these are not going to be running in parallel per se. That is, they're not going to be separate processes. It's the same consumer, and it subscribes them basically to both topics. And then as long as you treat each of these data frames independently, you can then use branching, which we'll go over here shortly. And you can do all the different functionality that you would normally expect with it, as long as you don't try to make the different data frames interact. Like I couldn't do sdfb.update and then or filter and use SDFA to try and filter it with. It just will not work. So just know if you treat them like the other data frame doesn't exist, they will both operate simultaneously. And like we talked about earlier, app.run will automatically detect all the data frames. So super exciting feature. But now let's talk about how you can then use this alongside branching if you wish. Now, in order to make branching work, there is one larger overarching change that we had to make that is going to be necessary for you to do regardless of whether you use branching or not. Now, again, things are backwards compatible, so if you don't make this change, it'll still work. But just know going forward that you no longer need to provide what SDF that you want to run. So let's take a look here. So in the current version, or version 2.x, you have to basically say app.run and then hand the SDF that you made. Well, now in 3.0, no matter how many SDFs that are made, they are going to be automatically tracked. And this is super important for branching, which essentially under the hood is making multiple SDFs, and we have to know how to basically path those out. So just know that from here on going forward, you no longer need to hand the SDF. It's going to know how to use it. And like I said, this is fully backwards compatible with 2.x, so if you still hand it that, it's just going to give you a deprecation warning saying, hey, in the future, we don't use this anymore. So at some point, you are going to need to remove it, but in terms of upgrading right now, you should be fine with using it. So with that, let's go ahead and talk about the other changes that this enables. All right, and at long last, we're going to talk about branching. But what exactly is branching? Well, the name is probably indicative of the functionality you might expect, but let's briefly go over it. So branching is basically the ability for you to, at given points in your SDF operations, as you can imagine with a graph representation here, this is your typical 2.0 SDF graph. So each operation here, A, B, C, D, is like an SDF.apply. You chain them together, your data changes along the way, and that's what you're capable of doing. But now with branching, as you can see here at, say, operation B, you'll be able to fork your operations, which also includes copying the data, and create independent processing branches. And you'll be able to make as many of them as you'd like. And so as you can imagine, this is going to open up a lot of possibilities, especially since it clones the data. So now you'll be able to have different data structures at different points, which was previously not possible with SDF. Now you could obviously mask some operations inside an apply function, for example, and hide it all in that, but sometimes you would lose some of the niceties, like for example, if you were going to produce to multiple topics, that just simply wasn't possible in a sanctioned way inside that apply function. So this is going to make all of that behavior a lot more native in SDF, which we're really excited about. So in terms of the why might you use branching, really, if you have any sort of conditional behavior that is making transformations on that data, and you have different data structures, and you might need to produce to multiple topics, which of course themselves are going to expect different data structures, well, branching is really going to solve a lot of problems for you. On top of that, because of these problems that people encountered, you might be able to take many applications that you've written that do very small specific behaviors and consolidate them into single applications or a few applications, which is also going to help managing a lot of applications a lot easier for you. But with that, it's obviously we're kind of talking in abstracts here. Let's go ahead and take a look at a direct example and see how that applies. All right, so here I have a super basic example just to showcase some of the very simple but obvious differences between 2.0 and 3.0. So here's our boilerplate. We have our application, and we have our input topic and two output topics, A, B, and X, Y. And I'm going to have a message that has 4 columns, columns A, B, X, and Y. So very straightforward. Go ahead and scroll down here. So I'm going to have basically 2 different versions of this application. I've got 2.0 and 3.0. And so looking at 2.0, we basically got, we're taking a subset of columns. We have columns A and B, and then I want to output that topic AB. And then later on, right after that, I want to take a subset of columns XY and produce that to topic XY. Very, very straightforward. Unfortunately, for those of you familiar with 2.x, not exactly as straightforward as you might hope. And this is largely because of the linear nature of operations with 2.x. Basically, once a transformation happens, that is the state of the data at that point. So in this case, once we take a subset of columns A and B, well, that's the only columns that now exist in that message going forward. So you'll successfully produce the output topic AB, cool. But then once you try to take another subset of X and Y, well, those columns don't exist now, and now you get an exception. No fun. Well, let's take a look now at 3.0, where branching comes to the rescue. So as you can see, I actually have a very similar amount of code And in fact, it would be exactly the same if I hadn't added this line here, which I'll talk about in a second. But as you can see, the only real difference with branching is I just simply had to change the names of the variables. And with app.run here, you can see I don't have to specify the SDF, and that's because it automatically tracks all the things it needs to track, which, as we talked about earlier, super nice. So with this, we make our SDF as the same just like before. Now, in this case, if you were to do this conditional operation, which I'm basically filtering all rows where column A is greater than 100, and then I just want to print them out. And if you did this previously with version 2.0, you would effectively filter all the rows for everything downstream of that. But because of branching in this case, I'm able to just print out the outliers here, and it will not affect any of the operations here below it. And so this is where all the power of branching comes in, along with, of course, this will function as you expect. So we take all the slices as you might expect. This will have columns A, B in it, and this will have columns X, Y. So with that, we're going to go ahead and go into some of the more advanced techniques behind branching and really how you can correctly make branching, because here we've obviously shown you a correct version of it, but we haven't really talked too much about the actual how. So let's get into it. All right, so now that we've whet your appetite a little bit with branching, let's go ahead and go a little bit deeper into how you actually generate a branch. And luckily, for the most part, you'll be able to apply pretty much everything that you know about SDF manipulations to branching. The main difference, and we alluded to this previously, is that the variable assignments are going to be a little bit different. So kind of jumping back to our original basic example, if you'll recall, we originally had this SDF. And then rather than just reassigning to the same SDF over and over again, we now have the option to instead, in order to branch, assign it to a new variable. And that's really about as simple as it gets. There's a few other stipulations with it, such as, for example, you are now allowed to use in-place operations to attempt to start branching, mostly because in-place operations still treat it as a linear operation. And we'll show you what that looks like here shortly. And for those of you who aren't familiar with what that means to be in place, they're basically operations that you don't have to do a variable assignment if you don't want to. So that includes things like toTopic, print, update, and drop. So, and again, if you really want to, you're allowed to still assign those if you wish. That's an optional thing, but you still will not be able to branch with them if you do that. So just be aware of that. So yeah, all you have to do is store those as new variables, and that's effectively all you have to do. And with that knowledge, let's go ahead and take a look at a slightly more advanced example just to give you a sense of what is possible with branching. So in this example, I basically have two functions that I have designated. I'm going to have an add and subtract function. And basically you can imagine these as my Lambda functions. I'm going to use add only when I do sdf.apply. And then I'm going to do subtract only when I do sdf.update. And so the idea here is I have a dictionary. It's a dictionary with key of foo and value of 0. So nothing super exciting. I'm just adding and subtracting numbers to this. That's the whole purpose of this. So with that out of the way, you don't even really need to look at this other section of it. Just know that's how that is being applied. So with this, I now have an application. And I have my input topic that I'm reading that foo value from, and now I'm going to do my data manipulations. So I first initialize my app.dataframe, and I have my apply function here, and all I'm doing with it is adding 1, right? So nothing sophisticated to start it off with. And then now I want to go ahead and add some branches to it. So now I have SDF branch 1, 2, and 3 that I'm doing some operations with. So I'm immediately branching off of this initial SDF. And I'm, of course, giving them unique names here. And then I also have branches 2A and 2B. So I want to point out a couple things going on here. So first of all, with my branches, I have actually made 3 different branches at one point. So you can do more than 2. You can do as many as you'd like. On top of that, I can do branches of branches. So I started off here with SDF branch 2, right? And now I have branches 2A and 2B. So you can fork off of as many that you like, as long as they're valid operations. So that's very, very exciting. Now here's where I also want to introduce some of the trickery or complexity around if you try to do an update, for example. So here, as you can see, we originally did some branching here. If this was an apply operation, this also would be a valid branch generation, you're allowed to generate them anytime you want. You don't have to generate them all together here like in this cluster of them that I did. So this normally would be valid, but because we tried to generate a branch using update, well, it doesn't quite work out that way. So how does it work out? Well, we have a diagram here that will kind of show you the data flow that we have going on here. So we're reading from our topic, we're adding 1, and here you can see all of our branches. So we have add 30, we have add 500, we have add 9,000. You can see where in our branch 2, we have the add 66 and 77 as its own branching. But here is this SDF update where we tried to do our subtraction of 1, 2, 3. And basically, as you can see, it did take our SDF. It did add the operation to the SDF like we would have expected. So it's kind of branch-like, but it effectively added it in place. So as you can see here, it created a chain of operations where we then have the print. That would be this print right here. And then we also had the update of 456, where it was not actually branched off of here. It was a continuation here. So this is why you can't generate branches with those in-place functions. So just be careful with that and understand this is the behavior that you'll see when you try to do something like that. So this is kind of a long-winded way of saying that update has effectively not really, update-like or in-place operations have effectively not changed their behavior overall. They effectively work in the same fashion. So with that, we're going to go ahead and move on to talking about what are the other limitations that you might run into with branching. Now that we've outlined how you can use branches, let's talk about the ways that you cannot use branches. And luckily, there's not very many limitations, but you should be aware of the limitations that do exist. And honestly, one of the largest takeaways here is that branches should be treated as independent entities. They cannot interact with one another. And this is also true with multiple SDFs when you're using multiple topics as well. You just got to pretend like the other ones don't exist. And so what I largely mean by that here, we have a few different examples of what that looks like. So in this case, here's some valid operations. Largely what you see here is you take the same SDF and you are doing operations with that same SDF through the whole time. Now, you could also, of course, as you can see, I can also set it to a different end SDF, so SDF-B here, which is not SDF-A. So that is also valid. So you can generate branches that way like we talked about before. But what you cannot do is, as you can see here, I'm using SDF-B and using SDF-A inside SDF-B, basically filtering with that, and that's just not a valid operation. Same thing when you're doing column assigning. So if I'm trying to assign a column to a given SDF-A here, that's fine. As long as I use SDF-A to do operations to assign that value, I'm good. I can even use multiple columns. So all the things that used to work before, totally valid. Where it falls apart is if I'm trying to assign to a different SDF. So as you can see here, I have SDF-A and B, and I'm trying to use that to assign to a different SDF-C here. And basically, this just won't work at all. It won't work for several reasons, because you're trying to add A and B first of all, and then you're trying to assign it to C. Just not valid whatsoever. So all of these would have to be the same if you wanted to do this operation. Another thing we highly recommend against, you might be tempted to do this with the introduction of branching, and that is saving things to a variable. So let's say I make a filter and I assign that filter, and here's my filter, it's SDF.apply, I do my function and I call that my filter. And then in the next step, I proceed to do that filter rather than putting this SDF.apply directly inside here. We highly recommend against it. It only works in very, very particular circumstances, and so we just outright do not recommend you do it. So this way you make sure that everything works as expected. Now the good news is most of the things that you're going to try likely should raise exceptions, but we do want to point these all out just in case that that is not true. But other than that, the only other thing to probably be aware of is that every time that you do a branch, you are copying the data. So the more that you do that, the more that you're going to generate copies. So just be mindful of where you make branches and try to do them in smart ways, like say after doing some data filtering, for example, because that will dramatically cut down on any performance loss that you might incur. And one last thing about branching, guys, I have not exhaustively covered literally everything that has to do with branching. I've covered a lot of the fundamentals to kind of get you started, but I would definitely take a deep dive into our branching documentation because it covers some other things that you probably want to be aware of, such as execution ordering or using with state, like with stateful applies, because there's some interactions there you should be aware of. So go ahead and check that out. You can definitely get all kinds of additional information there and see some examples as well. All right, so that's all I've got for you for version 3.0, but I want to tease you a little bit with what we have on the horizon. So right now we're currently working on merging, which, as you can imagine with branching, it would be nice to be able to reconsolidate those down into a single streaming operation. And then we're also working on kind of a similar equivalent called joins, which is being able to take various topics and combining messages based on different conditions. And then we're also working on sliding windows, which is going to be able to give you a more granular level operation for windowing. So a lot of exciting stuff there. And along that, we will continue to be adding various sources and syncs to make your integration life a lot easier. So be sure to keep an eye out for all those really exciting features. They're not too far from here. And that's all we've got for you for this release. Thank you so much for tuning in, and be sure to like and subscribe so that way you can stay up to date with all the latest features and changes in Quix Streams. But until then, I'll see you guys in the next video. Thank you so much for watching.